Nimbostratus clouds are the heavyweights of the sky, the ones that signal long stretches of rain or snow. Unlike their fluffy, white counterparts like cumulus clouds, which often evoke feelings of joy and carefree days, Nimbostratus clouds are often associated with a sense of gloom and the anticipation of a wet commute. They drape themselves across the sky like a thick, gray blanket, obscuring the sun and casting a dull light upon the world below. Imagine looking out your window on a day when the air feels heavy with moisture. The sky, once a vibrant blue, has transformed into a canvas of monotonous gray. This uniform sheet of cloud, stretching from horizon to horizon, is a telltale sign of Nimbostratus clouds. Unlike other cloud types that have distinct shapes and boundaries, Nimbostratus clouds are relatively featureless. They lack the puffy, cotton-like appearance of cumulus clouds or the wispy, delicate strands of cirrus clouds. Instead, they present a uniform, flat base that hangs low in the sky, sometimes appearing to merge with the horizon. This featureless nature is a key characteristic that sets them apart and contributes to their somewhat ominous reputation as harbingers of prolonged precipitation. The formation of Nimbostratus clouds is a fascinating meteorological process that involves the convergence of several atmospheric factors. It all begins with the rising of warm, moist air into the atmosphere. This air, carrying an abundance of water vapor, cools as it ascends, eventually reaching a point where the water vapor condenses into tiny water droplets or ice crystals, depending on the temperature. This process of condensation is often triggered by the presence of a weather front, a boundary between two air masses with different temperatures and humidity levels. When a warm front encounters a colder air mass, the warm air is forced to rise over the denser, colder air. As the warm air ascends, it cools, and the water vapor condenses, giving birth to clouds. In the case of Nimbostratus clouds, the upward movement of air is typically gradual and widespread, rather than sudden and localized. This steady ascent of moist air allows for the formation of a vast, uniform cloud layer that can extend for hundreds of kilometers. The continuous supply of moisture from below ensures that these clouds remain saturated, leading to prolonged periods of precipitation. Nimbostratus clouds are often described as a blanket across the sky, and for a good reason. They form a thick, continuous layer that can block out the sun entirely, casting a dull, gray light on the landscape below. This lack of definition is one of their key characteristics. Unlike other cloud types that have distinct shapes and boundaries, Nimbostratus clouds are relatively featureless, appearing as a uniform, gray sheet across the sky. Another defining characteristic of Nimbostratus clouds is their ability to produce prolonged periods of precipitation. This is a direct result of their structure and the continuous supply of moisture from below. The tiny water droplets or ice crystals that make up these clouds are constantly colliding and merging, growing larger and heavier until they can no longer be supported by the updrafts within the cloud. This steady, continuous release of precipitation is what sets Nimbostratus clouds apart from their more dramatic counterparts, cumulonimbus clouds, which are responsible for intense but short-lived thunderstorms. While cumulonimbus clouds unleash their fury in a sudden, violent downpour, Nimbostratus clouds deliver a more gentle, sustained rainfall that can last for hours or even days. In the world of meteorology, where predicting the future of weather is a complex and ever-evolving science, Nimbostratus clouds hold a special place. They are not just indicators of rain, they are valuable clues that help meteorologists paint a clearer picture of the atmospheric forces at play. The presence of Nimbostratus clouds, their height, thickness, and movement patterns, all provide valuable data points that feed into weather models and forecasts. For instance, the appearance of Nimbostratus clouds often signifies the approach of a warm front, a boundary where warmer air is advancing and replacing colder air. The gradual lifting of warm, moist air over the cooler air mass creates the ideal conditions for the formation of these rain-producing clouds. By analyzing the movement and characteristics of Nimbostratus clouds, meteorologists can track the progression of a warm front and predict when and where precipitation is likely to occur. Furthermore, the thickness of Nimbostratus clouds can provide insights into the intensity and duration of rainfall. Thicker clouds, often appearing darker gray in color, indicate a greater concentration of water droplets or ice crystals, suggesting heavier and more prolonged precipitation. Conversely, thinner Nimbostratus clouds, usually appearing lighter gray, are associated with lighter rainfall or drizzle. These subtle variations in cloud appearance, when interpreted through the lens of meteorological expertise, contribute to more accurate and reliable weather forecasts.